I went to Rensselaer up in Troy, New York for 5 years, got a bachelor's and master's in nuclear, got 2 nuclear degrees, cum laude, and on a AEC fellowship. Got a reactor operator's license while I was at RPI. I have a safety patent, 3 peer-reviewed papers. I wrote a best-selling book on Fukushima. But what's important here is that I was a senior vice president in the nuclear industry working for a dismantlement contractor, a decommissioning contractor. In Vermont, I was the first chair of the oversight panel that the governor put together on Vermont Yankee. But what's important for this discussion is that I was in the sailing club, and we used to race on the Hudson River. So it's important that the people up and down the Hudson realize that Governor Hochul's decision is not just preventing the release of tritiated water, it's releasing tritiated water into water that was already contaminated with PCBs. So my hat's off to New York State for recognizing that. I was the senior vice president in charge of a couple hundred engineers. And one of the things we did was dismantle power plants like Shippingport and other facilities. When you look at Indian Point, there's these domed shaped buildings, and that's where the nuclear reactor is. That's the nuclear containment. It's predominantly a vertical structure. And then along the river, there's a horizontal structure. It's brick, and that's the turbine hall. Inside the turbine hall is non-radioactive. None of the pipes, none of the major components in there have any radioactivity. And what they did at Zion is exactly what could be done at Indian Point. They gutted the inside of the turbine hall. They took all these heavy metal components out and sold them for scrap. And what I would do, based on all the experience I had in life, is to take all those components out, sell them for scrap, and make some money. Make a lot of money, probably $50 or $100 million worth of scrap metal in that facility. So that would leave you a huge building with an incredibly strong foundation that you could put tanks in to store the radioactive water that Holtec had been planning to release. Vermont Yankee, which is another plant that's being dismantled, in the basement of its turbine building, put bladders, put tanks in the basement of their turbine building to store radioactive water that had lots of tritiated water in them. And they didn't need an NRC permit, and they didn't need a town permit. It was a simple process of they had radioactive tritiated water. They needed a place to put it, and they stored it in rubber bladders in the basement of the turbine hall. So the storage of liquids like radioactive water in turbine halls has already occurred. So it's not hard to build a tank that holds tritiated water. So what I'm proposing is to bring in segments and build tanks. 5 of them would be all it would take to store 1.3 million gallons of water. After the tank is built, it's going to be in pieces, so there'll be seams, and then it gets a rubber liner in it. Again, I had teams of engineers who did things that others said couldn't be done, and a couple of weeks with 5 engineers, and we could solve this problem at storing waste in the turbine building. Now, tanks are vented on the top, and the reason they're vented on the top is so that as the water height changes, from either temperature changes or from water being added or being pulled out, so the tank doesn't collapse. But But that's not what we have at Indian Point. We've got a static tank. You're going to put a couple 100,000 gallons in each of these tanks, and the water's just going to sit there. And it's going to be in touch with the floor, which is probably at maybe 60 degrees and relatively stable. So temperature changes in the water are nominal. Now, there will be a vent on the top of the tank. So as you're filling it, the air in the tank will leave it and the water will come up. And also eventually when you drain that tank, you want air to come in and replace the water so the tank doesn't collapse. But in the meantime, in between those two times, in between filling it and draining it, evaporation is nominal. And you could even prevent any evaporation by putting essentially a rubber balloon on top of the tank, so that as the volume increased, the balloon would swell as the air got displaced, and as the volume decreased, the balloon would shrink as pressure pushed it down. You could keep easy track of the contents of the tank. Water evaporates faster than tritiated water. Tritiated water is heavier than water, so that if a tank evaporated, it would be the water that would be leaving and the tritium would stay behind. There's a couple degree difference in the temperatures to evaporate water off. So the normal evaporation will actually increase the tritium levels in the tank and put more water vapor into the air. But I don't think you need any of that. You can simply build a tank, put a vent on the top, and then put a rubber balloon over the top that expands and contracts as the temperature changes in the tank. It's not like you're going to heat this tank. You know, it's going to sit at 70 degrees for years or decades. So there's not going to be a lot of volume change. But whatever is in it could be collected in that balloon and would just drain right back into the tank. I don't think it's a difficult engineering problem. A tank is not going to fail catastrophically. It may start to leak over time, and based on the Fukushima experience, you could, instead of having 5 tanks with water, you could have 6, one of which is empty, so that if a tank were to leak, you pump the water into the fresh tank. In theory, you could continue to keep using those borated water storage tanks to store water in. This is not pure water, and it's certainly not just tritium in the water. This has been in contact with nuclear fuel, which leaks over time, and particles of nuclear fuel or other radioactive fission products, the radioactive rubble left after the fission occurs, are going to be in that water. They likely will have preferentially moved and lightly attached themselves to the walls of the pool. And so as the water is agitated, the radioactive fission products that are either in the water or on the wall are going to come off. The water in the borated water storage tanks and in the spent fuel pool has already been filtered and demineralized. So a demineralizer is 90+% efficient at gathering the radioactive material, so that the systems they use at Fukushima are really designed for a witch's blend of chemicals that don't really exist in Indian Point, because Indian Point didn't have a meltdown. So the system at Fukushima is not appropriate. But those systems, those filters, and those demineralizers exist at Indian Point, and are perfectly capable of continuing to reclean that water 2 or 3 more times to make sure you've got every last bit of it. If the first time gets 90%, which is where those are now, the next time we'll get another 90% of the 90%, and your 99% of the particles have been removed. But there's a lot of particles, so that's probably not enough. Another pass through that filter and demineralizer will be necessary to get the residual radioactivity. I'm really dissatisfied with the work that Holtec has done to characterize the water. Essentially they drew some water out of the center of the pool and said, this represents a homogeneous collection of 1.3 million gallons. And I don't believe that to be true. To do it right, what you'd need is maybe 10 samples in each tank and in each fuel pool. Some of these particles are heavier than water and will sink or gravitate into the corners. And as Holtec cleans that pool out, they're certainly going to be disturbed, and they're certainly going to be pumped into the Hudson if that's what they had planned to do. What I'm proposing is 30 or 40 samples total, but taken at different locations in the pool and analyzed in a reputable lab that we all have confidence in. There's several independent labs out there that frequently examine water. The state's process of examining the water prior to release is totally inadequate. So their concept of how to sample the water is inadequate. Where to send it to is the other question, though. I'm sure the state lab has competent people and competent procedures, but they don't do this every day. And the independent labs that we work with are in the business of routinely measuring radioactivity, quite likely in lower concentrations than the state lab is capable of. It's a cool sounding term, but basically you've got a toxic substance in the dirt at the bottom of the river, and now you're adding another toxic substance with tritiated water, and the combination of those two toxic substances is worse than just adding the two together. And that's called synergistic toxicity. Worse than PCBs are tritiated PCBs. So it's important that the people up and down the Hudson realize that Governor Hochul's decision is not just preventing the release of tritiated water, it's tritiated water into water that is already contaminated with PCBs. That combination is not linear. That means it's worse than the two combined. So my hat's off to New York State for recognizing that.